Hello. This is my submission attempt at the Google Coding Challenges for the Software Engineering Internship of Summer 2023. I'm going to cover them in order of radix sorts, unique rotations, and unusual height. Only one of these is the practice uh, of the Google Coding Challenge from that example set. Hold on, sorry, what was the order? Unique rotations. Okay, cool. So I have this program, so we're going to skip past the function for now. Basically, it organizes it by running a try and accept block to get the user to enter a number and how many digits you're allowed to swap or perform a reversal on. If the user doesn't enter a number, the search fails, but it keeps the code going. Otherwise, it performs the radix sort using that many digits into this printf block. Using the f strings, I was able to insert the numbers really easily. For the flag, right here, this tells the program if the user would like to continue or not, so even if they fail, they can just exit using this finally block that always executes. So that'll kind of be the gist of these while true loops for these three submissions. The maxed reverse function is where the star is on this program. Depending on or the number you put in, it will be converted into its string form. And for every character in its string form, we will only observe that character that is done with the sort and onward. So at the 0th sort, no characters are sorted yet, so it'll go for that. At any first, second, third, up to the nth sort, it'll start from the nth number and go forward. And that'll be shown in the current range that you are working on. If the max number of swaps hasn't been exceeded and the current range is not empty, meaning that you would just copy in the last number, then the max number becomes the max number of the current range, and we find the position of this number. If the position is not the first number, meaning that the first number is not the largest, you will flip every number from the first number up to that position. The position plus 1 here in the string slicing case is got to be plus 1 in order to not be running you short. This will make a copy of your string since strings are immutable, and then it will reverse it. The garbage collector will cover up that old string, I believe. Then the new string that we have will be the string that's already sorted plus this new flipped piece plus copying whatever is left on from the current range onto the string. And then this printf here will show our string for this rotation. Otherwise, if the position of the maximum number is the 0th position, then we just copy everything straight forward. This will print the current swapped attempts made, so if you only make one, you only get one swap, and then otherwise it will copy everything, and we will see that program here. So for any positive number, I'm just going to use some arbitrary number here. Cool. How many digits are we allowed to swap? I'll probably say 3. So it will swap the current numbers, as you can see here. The maximum number that occurs first is this 9, so it'll swap everything from 8 to 9, as you can see here. There was no old sort part yet, so it will be empty, and then the remainder would be this 9 2002. That will cause one of our swaps to occur, and then we would go into the next current range. As you can see here, 9 got sorted, then 9 ends up again. And after that third swap has occurred, everything else will be copied so that the max number that this number we gave can make using 3 reverses is 999,801,82002. So a fun thing about that is called a radix sort, and it can only sort out the first 3 radix points from left to right on descending order. However, this number could be anything you want. So if I were to do a larger number, that's just my birthday in number form. How many digits are we allowed to swap? 100. I want to make sure that this gets me the largest radix sort possible. I definitely don't exceed 100, and the number is sorted in descending order rate using the radix sorts. So this program is the unique rotations. Unique rotations, again, this has the while, try, loop, and what is going on there to make the program run. But for the function solution, I create a set because sets cannot have repeating numbers. So based on the numbers you input here, the program will attempt to find unique numbers based on the numbers themselves and their reversed counterparts. Google intended for this to be used with two-digit numbers only, so any number from 10 to 99. However, mine also considers the one digit and the three digits, but it considers all digits except it doesn't try to find unique interchangeabilities. It just does the reverses. So you will, while the list is not empty, similar from the last one, we'll take the first element from that list that's given in A, try to do a lookup of that number. If we get a position, then the number is not unique, and we will need to test that number. However, if Python throws an error exception that the number was not found, we know the number is unique and it can go into the set. So if the number is found, however, we have to run a check for a second occurrence of this number. So if there's three 32s, then the third 32 for sure cannot make a unique rotation or unique number from its rotation. So we will go ahead and just toss it out pretty much. So if the number we find does happen to make a third match, then because we are only searching from where we found this number in the spot after, from the spot after it up to the end, if that number is found, we will say false, which will prevent the loop from reversing it and, or yes, prevent this block from reversing it and attempting another lookup. However, if only one occurrence was found and it happens to be at point position, then what I want is, if true, perform a reversal using the old string copying method and return it to an integer so that it can be compared, and then try and do a lookup on the number while it's reversed. If the number is not found, then we know the reverse is unique, so add it to the list. Otherwise, it does nothing with the reverse number and tosses it out. At the very end, once all the numbers are scanned in, reverse or not, we have a set which only contains unique numbers, and the uniques length would be, or sorry, the unique amount of numbers would be the length of this set. So as you can see here, I'm going to use 41, 14, 41, 33, and 33. So this this list of numbers I gave has three unique numbers when you consider the reverses being 41, 14, and 33. We would lose one of the 41s and one of the 33s to make this set. The last one are the heights, and how Google presented this problem was that you are unaware of the order of the heights that will come into the room, but as they enter the room, if the student that enters is the tallest student currently, then they would make a new row. However, students would only fall into a new line. You could say like the line leaders, you know, if you had like a 8, then every number under that 8 would be in his line. So the way Google presented this is that if the number happens to have two 8s, or a number is equivalent to the line leader's height, that number would make a new row. In order to accomplish this, I created an object for nodes. This would be used for a linked list, where the value is passed in initially, and the next pointer holds a object that's none initially. And every node has a function for itself where it will print all the way into the end of its list of nodes. So again, right here, this is just a while true loop to take the inputs from a teacher that would probably be using this program if they're organizing students. So what I have is a list called B that will hold the objects for my keys. So this will be integer objects. Then I have the B's linked list representation, which will have the row organization of our keys or our students that have heights. So while the length is zero or is greater than zero again, so while we have students that still come through the queue, we pop the first value from that queue. This only executes if B is empty, so that way we don't have a short circuit. It will add this first height because he has to be the tallest first height and go ahead and create his line leader node object. Otherwise, if B has some values in it, we know that we can run some comparisons. So if the popped value is greater than the current maximum value of B, which means that if I have, for example, three keys, 8, 7, and 9, and the number I just popped is a 9, then the current max value is a 9, and I will need a new row because 9 is greater than all of these numbers, or greater than or equal to all of these numbers. However, if I had a 3, I know that it will just fall in somewhere. Or if I have a 10, it will clearly have to make a new row. So if the pop number happens to be greater than or equal to the current max, I go ahead and add the key without checking all the numbers because the max function should have returned that information for me. Then I go ahead and create its node as seen here. Otherwise, I know the key is shorter than or smaller in value than at least one of the other keys. So if this key, we check all the keys now for every key in B because B is not sorted. If the key is greater than popped, then the position we need to get the position of that key that is greater than the popped value. Go to its linked list index, and while the next value is not empty, go to that object's next value, and after that object's found a next value that is empty and suitable, it will create a node object and insert our value there. It stops at the first insertion here using this break because you cannot have multiple, like this person cannot be in multiple lines. They can be if taken out that way, but without that break statement, you'll have multiple insertions of this, I don't know, of this 3, and it will look like you have a much greater amount of students than you typically do. So after that, the list will be created with the keys, so the minimum rows required to fulfill that those stipulations that Google provided would be the length of our keys. And then this function returns a tuple that returns that list of our keys as well as linked lists. So if we go ahead and give that a run, I'm going to put my height in centimeters, my friend's height, a bunch of random heights that are kind of near the area, 190, 200, and then we'll go with a few lower ones, so 180, we'll go with 179, 178, 223. So these are the list of our students that have came in. This would require 6 minimum rows given Google's stipulations, and I want to see how they would be organized. So 175 comes in, 162 comes in, 162 is shorter and ends up in 175's row. Then 166 comes in, same thing. 180 comes in, he's the new tallest, so he'll make a new row. 180 comes in, they're also the same height, so they make a new row. 190 and 200 also do the same thing. Then 179 comes in, who's shorter than 180, and 178 as well, so they'll end up in 180's line. Then 223 is the new tallest, so he will make his own new line. And this is the simplest organization. A teacher or professor, whoever's handling the lines, would look at this and go, okay, these numbers are organized in descending or ascending order. So if I wanted to evenly distribute these lines, the best thing to do is take the copies and move them into any lower line because they also are lower than that number.